Namaskaram students. Today we are going to see the molecular orbital theory. Shortly we can call this one MOT. So far we studied Lewis theory and valence bond theory. What is the use of these two theory means? We can find out the structure of molecule. Structure of molecule with the combining of Lewis theory and valence bond theory we can find out the structure of molecule. But what about magnetic? Magnetic it cannot explain the magnetic property properly. So that only now we are going to learn this molecular orbital theory. Through this molecular orbital theory we can find out the structure as well as magnetic property. We can explain the structure as well as magnetic property with the help of this molecular orbital theory. The next one, first of all, atom. One of the atom combined with another atom, it forms the molecule. We know well. Molecule means how many atoms join ma? 2 atoms. So this molecule will possess 2 atoms. Now the atom, suppose the atom for example it has s orbital. One of the atom it has s orbital. Another atom also having the s orbital means what will happen? The two s orbital joining together, it forms sigma. Through the valence bond theory we can know that sigma. So in molecule how many sigma will form? So how many sigma means? There is 2 sigma. One is sigma means bonding molecular orbital. The sigma means called bonding molecular orbital. Sigma star indicate that it is anti-bonding molecular orbital. So in molecule there are 2 sigma. One is bonding, another one is anti-bonding. Because molecule always combined with 2 or more atoms. 2 or more atoms combined together will form the molecule. So inside the molecules we are having different types of bond. One is bonding molecular orbital, another one is anti-bonding. Likewise pi means what is that? Pi bond will formed by side wave overlap. So pi also it has pi star. Pi means bonding molecular orbital, pi star means anti-bonding molecular orbital. So likewise, and then sigma bond, how can you form the sigma bond? Head on overlap. S orbital and s orbital head on overlap will form the sigma bond. The same way px. Here in this book the molecular axis taken as a x-axis as the considered as the molecular axis. So the molecular axis orbital only combine together and form the sigma bond, head on overlap, not combine, just joining the head alone, it form the sigma bond. The same way pi bond means side wave overlap. We already taken the x-axis as the molecular axis. So other than axis means y-axis and the z-axis. So py together form the pi bond and pz together form the pi bond. So keep it in mind ma. Py means always pi bond, pz always pi bond, but px is it form the sigma bond, and ss both the one combined together form the sigma bond. Now in MOT, that is molecular orbital theory, 1s. I am going to take the first orbital 1s. So 1s means ss means it forms sigma bond. So sigma bond means sigma 1s and sigma star 1s. So these 2 orbital combining to form the 2 molecular orbital. One is sigma 1s, another one is sigma star 1s. Because this one is a anti-bonding and this one is a bonding. The next one 2px means both the px will form the sigma bond. So that sigma 2px and sigma star 2px. The next one, and y 2py. Y means we get the pi bond only. So that pi 2py and pi star 2py. We get the molecular orbital like this. Okay, py means always form the pi bond ma. So that only we are writing the pi, and pi means it form the 2 orbitals in the molecular. One is bonding, another one is anti-bonding. The same way in pz, 2pz and 2pz. Why I didn't take the pz alone means the p orbital will form only second orbit only. From the second orbit only the p orbital will come. The same way d orbital will not come in the second orbit. They will come on the third orbit only. So that here one we are going to discuss only p orbital only ma. See that only pi 2pz and pi star 2pz. These 2 are molecular orbital. One is bonding, another one is anti-bonding. Why we get pi means because of this axis. Z-axis means it forms only pi bond. P orbital only form the pi bond because of lateral overlapping or side wave overlapping. Now you see that Sigma 1s. Sigma 1s means it's just like a one box. It is a orbital. Suppose in this orbital 2 electron accommodate. Means how can you write this one? Means sigma 1s. The 2 electron will indicate a subscript. Superscript, sorry. Superscript. We will write the superscript as a 2 electron. So this 2 is indicate that it is a 2. It possesses 2 electron. And then 2px. 2px also one single box. In that one we have 2 electron. Means how can you indicate this orbit? This electron means just you like write the sigma 2px. These 2 electron indicate that it contains 2 electron. In that one the pi 2py and pi 2pz both the one have same energy, because both the one having the pi orbital. Px having sigma bond, but py pz will have the pi bond. So that the pi means they have the same energy mass. So that together only we will write the boxes. And then here we have one electron. How can you indicate this electron? Means just pi 2p1 1 electron and pi 2pz 1 electron. Like this we will indicate one. The next one we will see in the PPT.
When oxygen in a liquid form, it was attracted towards the poles of strong magnet. It indicates that oxygen is a paramagnetic. But in Lewis concept and valence bond theory, they explained that oxygen is a diamagnetic. But Lewis concept in valence bond theory, the bond formation, it is based on the electron pairs, so that they can't explain the bonding nature of paramagnetic molecule. So that afterward the F. Hund and Robert S. Mulliken, they developed one bonding theory, name is molecular orbital theory. This theory successfully explained the magnetic behavior of molecule. Let's see the molecular orbital theory. The salient features of MOT theory. A molecule they formed with a combination of atoms. So the atomic orbital lost their identity and new orbitals formed. That new orbitals are called as molecular orbital. Then the shape of the molecular orbital, they depend on the shape of the atomic orbital. And also the number of molecular orbital, it is same as the number of combining atomic orbital. Then in molecular orbital, which one having lower energy, that are called as bonding molecular orbital. They lie on the below, that is bottom. And the molecular orbital which is having higher energy, they are called as antibonding molecular orbital. They lie on the top side. Then bonding molecular orbital, there are 3 types: sigma, pi, delta. The same way antibonding means how can we indicate it means asterisks. With the asterisk it is indicated means it is called as antibonding molecular orbital. That one also sigma star, pi star and delta star. In molecular orbital also the electrons are filled based on the Offer principle, Pauli's exclusion principle and Hund's rule. And bond order means it gives the number of covalent bonds, how many covalent bonds will be formed during the combination of atomic orbital. It is calculated with the help of bond order. Now bond order formula is Nb minus Na divided by 2. What is Nb means? The total number of electron it is present in the bonding molecular orbital, and Na means that A word indicate that it is anti-bonding, the number of electron present in the antibonding molecular orbital. Some students they misunderstand that it is indicated the orbital number, but it is not the orbital number. It is the electron, how many electrons accommodated in the molecular orbital, that number, that electrons number is Nb and Na. Now bond order 1 means it indicate that the molecule possesses single bond, and bond order 2 means it indicate that the molecule possesses double bond, and bond order 3 means the molecule possesses triple bond. Suppose the bond order we obtain 0 means that molecule doesn't exist. For example, the helium molecule. For example, I gave this helium molecule, it does not exist. We will see later. The letter H is called as atom. Then H2 means it is molecule. That H2 molecule, how will it form means when two hydrogen atom combining with each other and it form the hydrogen molecule. Now see the right hand side orange color box. In that one the hydrogen atomic number 1 means it contains only one electron. So in at atomic level the hydrogen electronic configuration is 1s1. Now see in the left hand side the 1s atomic orbital of hydrogen and also another 1s atomic orbital of hydrogen, they are going to combine and give the two atomic orbital means how many molecular orbital will form? Two molecular orbital they will form in between the atomic orbital. It is indicated as sigma 1s and sigma star 1s. Sigma 1s means it is a bonding molecular orbital. In that orbital there is two electrons are present. It is from the 1s of atomic orbital of hydrogen and also another 1s atomic orbital of hydrogen it come. And sigma star 1s there is no electron but the atomic molecular orbital antibonding molecular orbital we get ma, but there is no electron because that 1s of hydrogen it contain only one electron. So that only one electron from the two hydrogen atom it will be formed in the sigma 1s alone. It never goes to sigma star 1s. Then now bond order. Now we have to write the electronic configuration of molecule, hydrogen molecule. I underline the blue color. So see the blue color. In sigma 1s how many electrons are present? 2 electron. In sigma 1s 2 electrons are present. So we have to indicate that sigma 1s and in superscript 2. That superscript 2 indicate that it is 2 electrons are present in the molecular orbital of hydrogen. Now we are going to calculate the bond order Nb minus Na. In Nb means the bonding molecular orbital how many electrons present? 2 electron. But in anti-bonding that is sigma star 1s there is no electron, so we have to put 0. 2 minus 0 divided by 2 we get 2 by 2 is equal to 1. So bond order 1 means in between the hydrogen atom we get one single bond. Then in this molecular orbital in sigma 1s it is have the paired electron. There is no unpaired electron, so it is a diamagnetic. It is an important question mark. Why helium molecule does not exit? First of all, the helium atomic number is 2. Atomic number 2 means it contains how many electrons? 2 electrons. So for that atomic level, the electronic configuration of helium is 1s2. Now see the left hand side, the 1s atomic orbit of helium, it contains 2 electrons. The same way another 1s atomic orbital of helium, it also contains 2 electrons. Then that 1s atomic orbital combining with each other, it forms the molecular orbital of helium in between them. Now see the center, how many orbitals are there? Sigma 1s and sigma star 1s. This sigma and sigma star are molecular orbital. It is obtained by combination of atomic orbital of helium. It is left hand side and right hand side present ma. They combine and then form molecular orbital of helium. Now in 1s atomic orbital of helium it contains 2 electrons. The same way another 1s atomic orbital of helium also contain 2 electrons. So 2 plus 2 how many electron? 4 electron. That 4 electron it is occupied in the molecular orbital. First of all it is occupied by sigma 1s. Afterward only it goes to sigma star 1s. Now you see the bond order. Now first of all we have to write the helium molecule electronic configuration. Now we are going to write the molecule electronic configuration. Don't confuse with the atomic electronic configuration with the molecular electronic configuration. Molecular electronic configuration means it contains sigma, sigma star, pi star like this. Now I underline that ma. First of all sigma 1s, that sigma 1s it contains how many electron? 2 electron. The same way sigma star 1s it also contains 2 electron. Now bond order Nb minus Na divided by 2. Nb means bonding molecular orbital. In bonding means sigma 1s how many electron? 2 electron. Anti-bonding means sigma star. In sigma star also there is 2 electron. So we have to put 2. 2 minus 2 0. So bond order 0 means that molecule does not exist. So that helium molecule does not exist. To get the wave function of molecular orbital, we have to solve the Schrodinger wave equation. But it is very complex method to solve the Schrodinger equation. So that we have to use approximation method. The most common approximation method is linear combination of atomic orbital. Here the psi is the wave function of atomic orbital. Now consider two atoms, one is A, another one is B. The wave function of A atom is psi A and wave function of B atom is psi B. When we get the molecular orbital by combining these two orbital, we get one of the bonding molecular orbital, that is psi B, by adding psi A plus psi B. Then antibonding molecular orbital, that is psi antibonding, we get by psi A minus psi B. Constructive interference of atomic orbital form the bonding molecular orbital. Then another one, destructive interference of atomic orbital, it form the antibonding molecular orbital. Now for first one, constructive interference. Now two 1s orbital, the two 1s orbital, the wave function they lie on the above the line, so that the wave function we can add the 1s orbital, 1f orbital wave function we are going to add mass, so that we get the oval size. You see the blue color, the oval size, it indicates that it is a bonding molecular orbital. We get the oval size by adding 2s orbital, that is 2 1s orbital. And now that bonding molecular orbital indicated by sigma 1s orbital, that oval size is containing 2 electron from the 1s orbital. Now destruction interaction, here also 1s orbital going to combine. But what is the difference between the constructive and destructive means? In constructive interaction, the wave functions are above the line, but both the wave functions are above the line. In destructive interaction, one of the wave function of 1s orbital is above the line and another wave function of 1s orbital is below the line, so that they are going to cancel. Now we get the antibonding molecular orbital. Just we are going to separate the atomic orbital, both the one are going to combine only, but not like the in the bonding molecular orbital. You see the bonding molecular orbital, what is the shape of that molecular orbital? It is a oval size. But in anti-bonding molecular orbital, you see the diagram, there is a blue color, dark blue color and green color. These two orbitals are not now atomic orbital, it is a molecular orbital. They are separated by node. So that it is separated by node means it is a antibonding molecular orbital. We have to indicate it as sigma star 1s, because sigma bond we get by combination of s orbital. Now molecular orbital diagram of lithium molecule. Lithium atomic number 3. Then electronic configuration of lithium atom. In atomic level, the electronic configuration is 1s2 2s1. Now see the right hand side. 1s2 means the 1s of one lithium atom and 1s of another lithium atom going to combine with each other. It gives a molecular orbital. S combined means it form the sigma bond, so that we have to put the sigma 1s, that sigma 1s, and also it form the sigma star 1s. That sigma 1s lie below the diagram and above the sigma 1s it lies sigma star 1s. Now the 1s both the atom contain how many electron? 4 electron. That 4 electron occupied in the molecular orbital. Sigma 1s contain 2 electron and sigma star also contain 2 electron. Now we move on to 2s. In 2s, how many electron present in the atomic level? Only 1 electron. The same way, another lithium atom also contain 2s 1 electron. That SS, that is 2s form sigma 2s bond in molecular orbital. The same way, sigma star 2s. 1s means it form sigma 1s ma. 2s means it form sigma 2s. Now the 2 electron it get from the 2s of 2 lithium atom, and sigma star 2s there is no electron because in atomic level 2s having only 1 electron. So totally how many electron in the atomic level means there is 2 electron only in 2s orbital. So that the 2 electron goes to sigma 2s alone, not goes to one of the electron, not goes to sigma star 2s. Now the electronic configuration of lithium molecule, the blue color line in between the atomic orbital we have to write ma. First of all, you start with the lower, that is sigma 1s. Sigma 1s contain how many electron? 2 electron. So we have to indicate sigma 1s 2. The next one, sigma star 1s. Sigma star 1s it contain 2 electron. The next one, sigma 2s. Sigma 2s it contains 2 electrons. So we have to indicate that sigma 1s 2, sigma star 1s 2 and sigma 2s 2. Now bond order means Nb minus Na. That orange color indicated that is bonding ma, and red color means it is anti-bonding. Then orange color, how many orange color I indicated? Sigma 1s 2 electron and sigma 2s 2 electron. 2 plus 2 4. And red color means it is 2 electron, anti-bonding contain 2 electrons. So 4 minus 2 divided by 2, we get 2 by 2. 2 by 2 means 1. Then bond order 1 means the in between the lithium atom single bond is present and all the electrons are paired only. In molecular orbital, all now you consider only the molecular orbital, don't see now atomic orbitals. The molecular orbital which where they present ma in between the atomic orbital. Now concentrate only on the molecular orbital. There is no unpaired electron, so that they are diamagnetic. Boron atomic number 5, electronic configuration in atomic level is 1s2, 2s2, 2p1. First of all, 1s of one boron atom and 1s of another boron atom combined with each other, it form the molecular orbital. In between the 1s orbital we have to write ma sigma 1s, sigma star 1s, and sigma 1s it contains 2 electron. It recover from the 1s of 2 atomic orbital. The same way, sigma star 1s also it contains 2 electron. The electron from the 1s of the 2 atomic boron atom. The next one, 2s orbital contain 2 electron. The 2 electron combined with each other, it form the molecular orbital, that is sigma 2s and sigma star 2s. These sigma 2s and sigma star 2s also it get the 2 electrons from the 2s orbital of boron atom. The next one, in 2p orbital, that is 2px, 2py, 2pz. The 2px is considered as a molecular axis. So 2px combined with each other, it form the sigma 2px. Then 2py and 2py it form combine in the side wave overlap, so that it form the pi 2py. The same way in 2pz also side wave overlap only, so we get the pi 2pz. Now see the molecular orbital. First one, the pi 2py, pi 2pz. Afterward only we get sigma 2pz. Then the same way in the anti-bonding molecular orbital also, pi star 2py, pi star 2pz. Afterwards sigma star 2px. Now in the atomic orbital in 2p, how many electrons are present? There is only 1 electron in the atomic orbital of boron, and another side another atomic orbital of boron, it contain only 1 electron. So totally 2 electron in 2p z. Then 2 electron it goes to pi 2py and pi 2pz, because in salient features it indicate that based on the Offa principle and Hund's rule and then Pauli's exclusion principle only the electrons are accommodated. So based on the Hund's rule, first they fill up the off field, after only it goes to higher energy level. Then now we are going to write the electronic configuration of boron molecule. You start with the sigma 1s. Sigma 1s, it contains 2 electrons, so sigma 1s2, and sigma star 1s2, and sigma 2s, it contains 2 electrons, so sigma 2s2, sigma star 2s also 2 electron, and pi 2p y, it contain 1 electron. We have to write pi 2py1, and pi 2pz, it also contain 1 electron. Now bond order means which are all bonding means I indicated the maroon color round. The maroon color round alone you have to calculate. Maroon color round means first sigma 1s, it contain 2 electrons, sigma 2s 2 plus 2 4, and pi 2py pi 2pz, there is 2 electrons, so totally 6. And anti-bonding, it indicated by circle, red color circle. You see that sigma star 1 is 2 electron, sigma star 2 is 2 electron, 2 plus 2 4, so 6 minus 4 divided by 2 we get 1, 2 by 2 1. And here in molecular orbital, pi 2py, it contain 1 electron, and pi 2pz also 1 electron, they are not paired, so we have 2 unpaired electron, so they showed the paramagnetic character. Carbon atomic number 6. So electronic configuration of carbon atomic level is 1s2, 2s2, 2p2. In 1s, we by combining of 1s orbital, we get sigma 1s, sigma star 1s. That sigma 1s, it get the 2 electron from 1s atomic orbital of carbon atom. The same way sigma star 1s also, it get the electron from the 1s atomic orbital of carbon. And 2s of carbon 2 atom noma, that 2 carbon atom combine with each other, it gives sigma 2s and sigma star 2s, that electrons also filled. Now we move on to 2p orbital. In 2p orbital, how many electrons are present? In 2py 1 electron and 2pz 1 electron. Then xx, we will form the molecular axis. X is considered as a molecular axis, so that it form the sigma 2px, but 2py and 2pz, they form the pi 2py and pi 2pz. Here the 2p2 of one carbon atom, another 2p2 of another carbon atom, so totally 4 electron. That 4 electron first filled by pi 2py and pi 2pz based on the Hund's rule. Afterward only it goes to sigma 2px. Now bond order. Bond order means first you see the orange color circle, that is bonding electron. How many bonding electron? Just count the electrons of orange color circle ma. We get the 8 electron, and next we have to count the red color circle, there is 4 electron, and 8 minus 4 we get 4, 4 divided by 2 we get 2. So bond order 2 means in carbon there is double bond is present, and the molecule, it does not have any unpaired electron, so that it is a diamagnetic one. All the ones are paired, all the electrons are paired, means you have to see the molecular orbital alone, don't see the atomic orbital ma. So all the electrons are paired in molecular orbital, means they are called as diamagnetic. Nitrogen molecule, the nitrogen atomic number is 7. So electronic configuration of atom is 1s2, 2s2, 2p3. The 1s combined with each other, it forms sigma 1s, sigma star 1s, and the electrons are filled based on the 1s electron. 1s electron, it contains 2, 2, so totally 4. That 4 electron is occupied by sigma 1s 2 electron and sigma star 1s 2 electron. The same way in 2s orbital also 2 atom of nitrogen combine with each other, it form the sigma 2s, sigma star 2s, and the corresponding electrons are filled in the sigma 2s, it contains 2 electron ma, it get from the 2s orbital. The same way sigma star 2s also, it contains 2 electron, it get from 2s orbital of nitrogen atom. The next one 2p3. In 2p3 means 1 electron is occupied by 2px, 2py and 2pz. We know the px is a molecular axis, so px combined means it form sigma 2px, and py pz both the one lateral overlap undergo, and then it forms the pi. So pi to py and pi to pz both the one lie on the same level, because both the pi orbitals having same energy, so that they are lie on the same level. But sigma 2px, it has somewhat higher energy, so that it lies above the pi to py and pi to pz. Now in 2p3 there is 3 electron in one nitrogen atom, and also in another nitrogen atom contain 2p3. So totally 6 electron. That 6 electron in the molecular orbital is filled with, first of all it is filled in pi to py, pi to pz to 2 electron. Afterward another 2 electron it goes to sigma 2px. Now we have to calculate, first of all we have to write the electronic configuration of nitrogen molecule. You see the molecular orbital of nitrogen, which one is center. First with the start with the sigma 1s 2 electron, sigma star 2 1s 2 electron, sigma 2s 2 electron, sigma star 2s 2 electron, pi 2py 2 electron, pi 2px 2 electron, pi 2pz 2 electron, and sigma 2px it also possesses 2 electron. Now bond order means NB means orange color circle you have to concentrate, and Na means you see the red color circle. So in orange color means how many electron? 10 electron. Sigma 1s 2 electron, sigma 2s 2 electron, pi to py, pi to pz it contains 2 electron, and sigma 2px 2 electron. So totally 10 electron. In antibonding sigma star 1s and sigma star 2s, so 4 electron. So 6 divided by 2 we get 3. So bond order 3 means in between the nitrogen atom there are triple bond is present. In bond now molecular orbital all the electrons are paired, there is no unpaired electron, so it is a diamagnetic. Molecular orbital diagram for oxygen molecule, oxygen atomic number 8. So electronic configuration of oxygen atom is 1s2, 2s2, 2p4. Now we are going to write the molecular orbital of oxygen atom. With the help of 1s we get sigma 1s, sigma star 1s, and the corresponding electron will be filled. The next one 2s combined with each other it form sigma 2s, sigma star 2s, and also they are filled with the corresponding electron. The next one the 2p, how many electrons having in oxygen? 4 electron. That 4 electron we indicated by 2px, 2py and 2pz. Then one of the orbital contain 2 electron, other orbital contain 1 electron. But here one difference we have to see. In previous slide in nitrogen molecule, the pi to py, pi to pz, first of all they present in the lower level, afterward only sigma to px come. But in oxygen molecule it is a heavy element, so that first of all the sigma to px will come first, afterward the pi to py and pi to pz will be lie above the sigma to px. Now in 2p how many electrons are present in atomic level? 4 electrons, and in another oxygen also 4 electrons. So 4 plus 4 8 electrons. That 8 electron will fill in sigma 2px first 2 electrons, afterward 4 electron in pi to py, pi to pz, afterward 2 electrons. The 2 electron they based on the Hund's rule. First of all pi star to py it contains 1 electron, afterward pi star to pz 1 electron. It is based on the Hund's rule. Now the electronic configuration of oxygen molecule, sigma 1s 2 electron, sigma star 1s 2 electron, pi sigma 2s 2 electron, sigma star 2s 2 electron. You see the diagram, you can easily write the electronic configuration. And after sigma star 2s, sigma 2px 2 electron, pi 2py 2 electron, pi 2pz 2 electron, pi star 2py 1 electron, pi star 2pz 1 electron. Now bond order, the orange color bonding molecular orbital, count it, you get 10 electron, and red color means you count that you get the 6 electron. So 10 minus 6 divided by 2 we get 2. If bond order 2 means the molecule contain 2 bond, double bond. And here in pi star 2py, pi star 2pz, there is unpaired electrons are present, so that oxygen is a paramagnetic character. Let's see the molecule of carbon monoxide. That carbon monoxide we get from the combination of carbon atom and oxygen atom. Carbon atomic number 6, electronic configuration of carbon atom is 1s2 2s2 2p2, and electronic configuration of oxygen atom is 1s2 2s2 2p4. In one side we are going to write the atomic orbital of carbon, and another side we are going to write the atomic orbital of oxygen. In between the atomic orbital of carbon and oxygen, we get the molecular orbital of carbon monoxide. Now the 1s orbital combined with each other gives sigma 1s and sigma star 1s, and in these two orbitals the electron will be filled, and afterward 2s of carbon and 2s of oxygen combined with each other, it formed the molecular orbital of carbon monoxide, that is sigma 2s sigma star 2s, and these two orbital filled with the help of 2s orbital of carbon and oxygen. The next one, in carbon in 2p level how many electrons are present? 2 electron. But in oxygen in 2p orbital 4 electrons are present. So 2 plus 4 totally 6 electron. That 6 electron will occupied by pi 2py, pi 2pz and sigma 2px. Now we are going to write the electronic configuration of carbon monoxide from the sigma 1s. Sigma 1s, it contains 2 electrons, so 2. And sigma star 1s 2 electron. Sigma 2s 2 electron. Next sigma star 2s, it contains 2 electron. And pi 2py 2 electron. Pi 2pz 2 electron. The last one sigma 2px, it contains 2 electron. The next one, bond order. Bond order, orange color bonding molecular orbital and red color circle is antibonding molecular orbital electron. You count means we get the number of electron in bonding molecular orbital is 10 and number of electron in antibonding molecular orbital is 4. So 10 minus 4 divided by 2 we get 3. So bond order 3 means in between the carbon and oxygen triple bond is present. Then in molecular orbital all the electrons are paired. There is no unpaired electron, so they are diamagnetic. Carbon monoxide is a diamagnetic substance. In MOT of nitric oxide molecule, one side nitrogen atom atomic orbital will occupy, and another side we are going to write the oxygen atomic orbitals. Nitrogen atomic number 7. So electronic configuration of nitrogen atom is 1s2 2s2 2p3. In oxygen atomic number 8, then electronic configuration of oxygen atom is 1s2 2s2 2p4. Now one side nitrogen, another side oxygen atomic orbital. In between the atomic orbital of nitrogen and oxygen, we are going to write the molecular orbital of nitrogen monoxide, that is nitric oxide. First 1s combined with each other gives sigma 1s sigma star 1s. Afterward we fill the electron. The next we move to 2s of nitrogen and 2s of oxygen will combine with each other gives sigma 2s and sigma star 2s. These orbitals are filled with the help of 2s orbital of 2 electron of nitrogen and oxygen. Next move on to 2p. In nitrogen it contains 2p3, that is 3 electron, and in oxygen in 2p orbital how many electrons? 4 electron. So 4 plus 3 totally 7 electron we are going to fill in the molecular orbital of NO. First of all, pi 2py, pi 2paz, it filled by 2 electron. The next one, sigma 2px, it filled with 2 electron. So totally we will now fill 6 electron. One more electron, it goes to pi star 2py. Now bond order, now electronic configuration of nitric oxide. First sigma 1s 2 electron, sigma star 2 1s 2 electron, sigma 2s 2 electron, sigma star 2s 2 electron, pi 2py 2 electron, pi 2pz it contains 2 electron, and sigma 2px it contains 2 electron. Next, the pi star 2py, it alone contain only 1 electron. It is indicated in superscript 1. Now bond order, see the orange color circle, it contains bonding molecular orbital. On bonding, number of electrons in bonding molecular orbital, how many electrons we get? 10. In circle, red color circle means anti-bonding molecular orbital, the number of electrons we get it is 5. So 10 minus 5 divided by 2, 5 divided by 2 we get 2.5. The bond order is 2.5. And molecular, in this molecular orbital there is only one unpaired electron present in the pi star 2py. So it is a paramagnetic substance.